Hi everybody, this is Art Soundler from Hindle Power, and I'm here to do a presentation on battery charger spec writing. Now, battery charger spec writing is kind of important because it's where you tell us, the manufacturer, what you want in your battery charger, what you want to use it for, what you want to do with it. So I consider this to be probably one of the more important presentations I ever do because it talks about the things that are important to you when you're specifying a battery charger. So we start out by basically talking about the essential parts of a specification. And the essential parts of a specification are basically looking at the introduction, the relevant standards and documents, application specifics, the required features, the alarms, the controls, communications, and drawing requirements, testing, and reporting. So in this presentation, we're actually going to go into each one of these with just a little bit more detail. So in the introduction, what you really want to do is let us know how you want to use the charger. What's it going to be used for? Switchgear, control, communications. The more we know about what you want to do with it, the better off we are in trying to figure out if your spec lines up and you got what you need, and maybe we'd even make some suggestions based on knowing that. Now, the next thing we talk about is design requirements, and that includes things like digital controls, although to be honest, most battery chargers today would have digital controls. There are a few analog requirements that do come up, mostly for the military, for things like hacking and so on. And then what does the output of the charger look like? By that, we're talking about the voltage, the current, and the filtering. And then think about some of the specific things that you might want in your battery charger. Now, the next thing that comes up are the standards. And NEMA PE5 is the most common standard that's been around for utility chargers. But we also we're working on IEEE Standard 2405, which hopefully will be out in about a year or so, which take NEMA PE5 even further. And it's actually being done in conjunction with NEMA, so it's going to be a harmonized document when it's all completed with NEMA PE5. Then there are various UL standards for safety, seismic, which is part of the environmental, and FCC Part 15, which if it's digital, you're going to have Part 15 no matter what. So first things first, we start getting into the application specifics. And in the application specifics, that's where you tell us exactly what you want. So for example, things like your input voltage. We need to know 120, 208, 240, single or three-phase. And the two-phase thing, by the way, basically I just put it up there because a lot of people don't always understand what two-phase is, and that's any voltage that's line to line. So 240 typically is two-phase, 120 is typically single-phase, but most people just consider everything that's not three-phase to be single-phase, and that works okay too. The next thing you want to talk about is your output voltage. And output voltage, there's a nominal voltage, say it's a 130 volt charger, but then we start talking about the specifics. How much range do you actually need in order for you to have the charger be suitable for your application? So for example, we need to know the cell type, number of cells, recharge voltage per cell for float and equalize, so that we make sure that the battery charger accommodates the range for the battery that you've selected. Then we get into DC output current. Now, DC output current, that's usually calculated, and we did a separate presentation on that, which you're welcome to look at. But basically in the spec, you either state the value of output current that you need, or you provide the details for us to calculate it. Those details simply are the ampere hours removed from the battery type, the recharge time, and the constant current you need accommodated. So with those things, we can actually calculate it as well using the current calculation methods. And then we get into the filtering level. The filtering level is another important factor. Left over from years and years ago, something called the old Bellcore specs, almost all chargers that were filtered were 30 millivolts. But realize that the Bellcore specs were written about 48 volt and 24 volt chargers, not 130 and 260 volt chargers. So to be honest, NEMA PE5 years ago for 130 volt chargers, raise the filtering level to 100 millivolts and 200 millivolts for 260 volt chargers. Now, there are various other considerations here. Just make sure that you tell us what you're interested in, what your application requirement is, and we'll find the filtering method that's best for you. Then we get into environmental, which includes temperature and altitude. And there in battery charger sizing presentation that we did, we tell you a little bit about what that really means and how that will affect the battery charger output rating. And then you want to get into things like the enclosure, NEMA 1, NEMA 2, which is a drip shield, and NEMA 4, 12, and 13, etc., which deal with the kinds of enclosures that can handle things like weather and hose spraying and things like that. And then, of course, the finish. Do you want the standard ANSI 61 gray, or do you want something fancier as a charger finish, or a different color? Now, the other thing that you start thinking about are things like protective devices, circuit breakers, and their interrupting capacities. And by the way, there's also another presentation we've done on that, so look it up and you'll be able to see our presentation on how to determine interrupting capacity. Also fusing, which generally I don't like to see fusing in battery systems because the chance for them to clear is a little bit easier than it is for a circuit breaker. SWC, surge withstand capability. Do you need lightning protection? Are you going to be using the charger in parallel with another charger? Or if you saw our presentation on best battery selectors, then you don't need parallel operation with forced load sharing. The chargers operate independently. And then other kinds of protections for environmental situations like fungus or static when things are very dry. So now, features are everything. So up until now, the spec is providing the minimum requirements for a product for your application. But now comes the hard part. Now you have to really kind of think about what is it you want the product to actually do. And we start off with the device platform. We at Hensel Power only offer SCR. There are other platforms, controlled ferro, switch mode, etc. And then, is it going to be an analog or digital design? And, as I mentioned before, you don't see too much requirement for analog design anymore. So pretty much you're always going to get digital, and that also gives you a lot more features and capabilities that you might not have thought about. Then we get into the float and equalize methods. So however you float and equalize, it might be automatic, it might be manual. So it's a good idea to understand what that is. And then we get on also to the regulation standard. Now, again, at Hensel Power, we offer 0.25% regulation on the output, and we suggest that that's what you just asked for. Input tolerance is another one. Usually on voltage, it's plus 10, minus 12%, and on input frequency, it'll be plus or minus 5%. So those are typical values. But again, what is it you actually are dealing with? That's what we need to know. Now, a couple other things that are kind of always important to know is how you're going to mount the charger. Now, if it's a big charger, it's going to sit on the floor. If it's a smaller charger, you might want to hang it on the wall. You might want to put a relay rack system in, anything like that. So again, this is all part of dealing with the design feature. The other thing is if you're in a very humid area and you're going to store the charger for a while, the charger's not going to be powered, you might want to put a cabinet heater in to cut on condensation. You don't usually need that if the charger is powered all the time, but if you have periods of time where the charger might not be powered, then a cabinet heater to prevent condensation is probably a really good idea. The other things you want to think about are enclosure type features such as locks and the kind that you want. And then the next thing you start thinking about metering. Now, interestingly enough, and this is one that I kind of like, is as we get more and more into digital chargers, the ability to provide more metering becomes easier. So for example, at Hensel Power, we have the AT Evo product, and the standard metering is output voltage and current. But if you wanted AC metering or ground fault metering, or even some of these other meters that are available, many of them we can do as digital. As a matter of fact, in the AT Evo product, ground fault metering is standard as part of the design. So again, let us know what you want, and you might be getting something even that is already in there. So that's always another important consideration. Now, alarms become very important too, and this is another case where alarms in a battery charger, there's a whole bunch of different alarms, and the digital designs give you a tremendous amount of alarm flexibility. It used to be pretty much just AC failure, high DC, low DC, charger failure, ground fault, and then a kind of a general alarm or whatever. But now we can alarm a lot of things, and again, with the new digital designs, we can even have custom design alarms. So you could think up some kind of an alarm, and we can easily put it in there without a lot of programming and a lot of effort. So if you're going to have alarms, make sure that you know what they are, you know what they want, and just state it accordingly so you get the alarms you're really looking for. So again, as I stated before, these are the standard typical minimum alarms that are going to be in a charger no matter what. So those are going to be in there almost automatically. But now you get into some of the more fancy, sophisticated, whatever. You have a battery discharge alarm, lets you know when the battery is actually putting out current. An important thing to know there is if you're going to put a battery discharge alarm in, it's actually measured through a shunt, so we need to know the maximum current of the load profile. The other is an end of discharge alarm. Now, end of discharge alarms are basically kind of low voltage alarms. They let you know when the batteries reach the end of discharge. And for lead acid batteries, and particularly valve regulated and even wet lead, knowing the end of discharge is important because you may want to disconnect the battery from load when you reach a certain voltage, because if it goes beyond that voltage going down, you could start to cause damage to the battery like sulfation and other things. Then you have other alarms that could either be custom or programmable. Again, imagination's the limit, but you need to tell us what they need to be. Then we start talking about various additional control systems that you can put in battery chargers. Things like remote battery temperature compensation. This gives you the ability to actually compensate the output of the charger based on the temperature of the battery. So as the temperature goes down, you want to put a little more current in. Temperature goes up, you might want to put in a little less current. And you want to know the cable length, we want to know the battery type, and we want to know how you want the sensor attached. And there's various ways to do it. Some of the other things that sometimes people think about is the ability to equalize remotely, or even more importantly, a remote shutdown, which could be used for any one of a number of reasons, including high voltage, high temperature, lack of ventilation, high hydrogen. So any one of a number of things could trigger a remote shutdown. And then various relays that would actually give you a relay closure for all of this. And finally, digital communications. And we just mentioned in here things like, we have DMP, Modbus, Ethernet, fiber. We also have IEC 61850. So there's a lot of different ways to do it, and there's a lot of different combinations. So make sure you're very specific about what you're looking for digital communications, what system we're communicating to, so that we can give you the kind of system that you really want. Now, another important feature that's become new now is, do you want the charger to actually report its activities? Do you want to know if it's going to store any testing or log any data on the system? And how easily is the data accessible? You want to try to make sure that the battery charger will give you data using something that might be very simply Excel spreadsheets, stored on SD cards. So you want to think about the fact that not only do I get the data, but is it easy to use? Do I have to learn a lot of programming and so on? And to be honest, you don't. So you want to try to get a battery charger that will give you that in simple, easy to understand terms, because that'll make it very useful. Now, let's talk a little bit about security. So it's important to think a little bit about system security. You want to have a charger that has multi-level password protection, so that this way not anyone can just walk up and change controls. Also, you want to make sure that the communication system is actually built to NERC CIP-003-7. And it may be set to either read and write or may be set to read only. But these are now the current standards for the utility industry. Now, testing and documentation is another thing. Generally, you probably want to have design drawings that depict the exact product that you want, the way it's built. And you want some testing documentation to confirm how it was tested. And each charger should be individually tested. So you can ask manufacturers, for example, for what their test procedures are and get a feel for that and make that part of your spec. You could refer to NEMA PE5. Either one of those things will work, but just realize that what you write down in testing that's not standard will also add cost to the product, and it's probably cost that doesn't really need to be added. So one of the things, for example, is you might just accept a routine test report, which I would recommend, or you can get a certified test report, which is where another engineer from the organization goes and witnesses your test for you and certifies that all the tests were actually done. So it gives you kind of an extra set of eyes that have looked at it. The last thing you could do is actually witness the testing yourself at the factory. Usually very expensive, not usually worth all that it's cracked up to be most of the time, but again, something that's always available. Now, you also may want to add in some special testing. Every so often we still see things like burn-in testing and so on. But one of the things that I'm just going to kind of mention to you is we hear burn-in testing all the time, but burn-in testing actually doesn't do you a lot of good. Most units are built in such a way that the burn-in testing provides little to no advantage. All of the components in a battery charger are solid state. They're not going to burn out over time the way things were years ago when you had vacuum tubes and you burned them in so that you had consistent operation. These things don't really exist today. Also, I know at Hindle Power we offer a 5-year warranty. So having us run the charger for several hours and you paying us for it at full load or partial load, it may seem on the surface to be useful, but for the most part, it's not really giving you anything. We power every charger that we make. We fully test them 100%. The boards have been already pre-tested for hours in static operation. We have a very low failure rate, and so providing that additional testing doesn't really buy you a heck of a lot. Now, also notice that you may be getting NRTL certification, similar to UL or CSA or something like that. And that is safety testing. So that's not part of the testing that's done for manufacture. It's part of the testing that's done in advance of the design. So when you start thinking about this, make sure your specification makes sense. Create a story with your spec. Make sure it flows so that everybody understands it. Be sure to provide enough specific product detail so somebody can actually respond with a quote. I can't tell you the number of times that I get specs where I don't really know what the customer wants because it's a lot of words but not a lot of statement about what they want. So it's usually a good idea to have a general specification and then an application-specific data sheet. Because remember, if you can't tell us what you want, how are we going to know? So here's some advice. Make sure that you did at least the minimum requirements. The AC input, the output voltage and current, the type of application you're going to use so that this way we know things like battery type, ampere hours removed, recharge time, etc. The filtering requirements would be nice to know. And take advantage of all the reference materials that are around. IEEE and NEMA has a lot of stuff that can tell you about battery charger products, but also most manufacturers actually publish standard specifications. Grab them, use them, they'll probably help you out. Also, a lot of utilities publish standard charger specs. Not a bad idea to look at them, see what they say, and then make yours better. So in summary, be sure to include all the elements that we discussed: the introduction, the documents, the application specifics, the required features, the alarms, the controls, the communications, drawing requirements, testing, reporting, and any special packaging requirements. And be sure that whatever you're specifying, that it's a product that's actually available. So if you have a specific requirement, explain it in detail. Try to have enough description so that somebody doesn't really need to ask a question. When you send it off to get a quote, they should be able to figure out what you want from what you wrote. Also, if you like a certain product, don't be afraid to use its characteristics in the spec. It's what you want. And also make sure that you put a job-specific detail page in every request for quote that you do. Because remember, the bottom line is if you don't know what you want, no one else will either. So again, thank you for attending our presentation on specification writing for battery chargers. If you have any more requirements or you have any information that you need, please give us a call. We'd be happy to help you out. Or go onto our website. Whatever resources we have are available to you, and thanks so much.